Hi everyone and welcome. The following is a video presentation for two different presentations here actually. We have engineering disciplines and engineering roles. This is all about discovering and learning about what kind of engineering things are out there and maybe finding some things that you're interested in to move forward with. So starting off here with engineering disciplines. Engineering, the term, the textbook definition is the application of mathematics and scientific principles to better improve life. There are four major fields of engineering. They call them the big four. You have chemical, civil, electrical, and mechanical. We will learn about all of those by the time you get into your POE class, Principles of Engineering, your second year course next year. And then most other disciplines are either a derivative or a combination or an extension of one of these big four main areas. All right, and so just taking a look at each one of those really quickly here. Chemical engineering would be applying scientifically the principles of chemistry, physics, and engineering to design and operation of plants for the production of materials undergo chemical changes during their processes. So they'd be responsible for new and improved products and processes relating to things like new fuels for rockets, reactors, booster propulsion, medicine, vaccines, serums, and plasma, and plastics, synthetics, and textiles. So all that is related to chemical engineering. Next, here looking at civil and construction engineering. These folks will be designing and planning and supervising the construction of facilities in both the public and private sectors. Projects vary widely in nature, size, and scope, of course, and things like space satellites, launch facilities, offshore structures, bridges, and buildings, and highways, our transit systems, the dams that we have to keep water back and also generate electricity, airports, irrigation projects, tunnels, treatment of distribution facilities for water. I mean, pretty much everything around us that we would need to either interact with or drive on or something like that was put together and designed by civil engineers. The next category, electrical or electronics engineering, also a really big field, deals with the motion of electrons and metals, of course. Work will be focused on either large systems, motors and generators, electrical circuits and buildings, power transmission systems, electrical generation plants, and so on. The fourth category is mechanical engineering. These folks will be applying the principles of mechanics and energy to the design of machines and devices, most often associated with devices that move, but also include thermal designs like you would have with an HVAC system in your home or here in the school. Vibration analysis, lubrication, gears and bearings. These are all the types of things that mechanical engineers think about when designing systems. And then, of course, we mentioned there are several offshoots of the big four. And so here is a look at some of those. We have aeronautical engineering dealing with flight and the movement of fluids inside the Earth's atmosphere. These folks would specialize on things like aerodynamics and propulsion, control systems, the structure of their flight vehicles. And then you'd have aerospace, or otherwise known as astronautical engineering. These would be dealing with environments not found on Earth, so as we enter into outer space. And then specialization of that work would be centered on propulsion cryogenics, materials and navigation, thermodynamic and cosmic radiation. The next category, agricultural engineering. Agricultural engineering blends engineering knowledge with soil systems, land management, and environmental control. So there are five specialty fields for that. You have soil and water, food, power machinery, structures, and electric power generation. Another category, architectural engineering, works with architects focusing on the structural integrity and a safety of the design. The structural engineering and this field are very similar. However, their main difference is the concern for aesthetics. So architectural engineers kind of work on designing a building from a holistic approach and really creating something that's interesting and unique, whereas they would then hand that off to a structural engineer or even a civil engineer to figure out how can this actually be built and be safe. The next category, the automotive engineering, design and building all types of vehicles from automobiles to trucks, tractors, bulldozers, and motorcycles. They, of course, would be working on engine design, structural design, tire design, those types of things. Another really Hot topic category right now is biomedical engineering, and this, of course, would be bridging the gap between physical and life sciences and integrating that with all of our STEM principles. This would look at bioengineering, medical engineering, clinical engineering, and so forth. Another category, computer engineering. All right, so designing computer systems with both hardware and software in mind. Just a fun fact here, the largest consumer of computers today is the automotive industry. And as you might have heard, over the past couple of years, they've been in a really tough spot with waiting for chips, which is really just a shortage based on silicon and material. And it's not that we don't have enough of it on Earth, it's just that it got really backed up during the pandemic and we just never got back up to producing those materials the way that we really needed them to be continued to produce as we were entering into our technological age in full stride for sure. All right, so industrial engineering, the next category, the design, improvement, and installation of integrated systems of people, materials, and energy to produce a product at the lowest possible cost. This would be dealing with design of systems for the manufacture of products and turning raw materials into machines or products themselves, and then workforce to operate that machinery. And of course, removal of finished products as well. Maintenance of the machinery, and analysis of manufacturing processes for cost. This is kind of like what we're doing with our special project right now for Pack Challenge. And then manufacturing engineering, design of manufacturing facilities for the product or products, dealing with physical plant layout, use of existing machines or buying new ones, purchase of rental facilities, purchase of non-producing facilities and equipment, and then packaging of the products and shipping to market. Also kind of what we're doing with our Pack Challenge project right now. Okay, and that is the end of this presentation. What I'd like to do now is just go ahead and flip right over to our second one for today, which is called engineering roles. And this is going to specifically talk more about what does the person do. We just saw a bunch of different categories and defined them a little bit, but what are people going to find themselves doing within these categories, right? So you have engineering roles here. Again, we have that same definition from the last slide. And then it talks about what is an engineer. An engineer is a person who is trained in and uses technological and scientific knowledge to solve practical problems. All right, so really great website for you here to check out, greatachievements.org. And also another great website, you'll be doing some research as a part of today's activity, engineergirl.org. And so again, we've got some major categories for what do engineers do: research, develop, design. It could be in the supervision role or even the management role as you get a little further along in your career. So from a research perspective, employing basic scientific principles in the discovery and application of new knowledge that will have commercial or economic value, developing existing or inventing new products, and then discovering truths about a subject. In the development stage, this can involve searching in library and manufacturing literature and patents for existing ideas, but it's also the actual construction and fabrication, the assembly, layout, and testing of scale models, pilot models, and experimental models for pilot processes or procedures that will work. Does not deal exclusively with new discoveries, but involves using well-known principles and employing existing processes or machines to perform a new or unusual function. Next category there, design. An engineer could find themselves in the design role. I think this is the one that I would find most interesting, and this is where you get to actually sit down and figure out what is this product going to look like and sketch it out, or take it into a CAD software and actually design it there. But anticipating all manners of problems that the user may create in application of the machine or product I mentioned, prevent user errors, accidents, and dissatisfaction. Just trying to think about how is the person going to use this product and how can I kind of think about ways that they might fail so I can make a better design so it doesn't do that. And then requires a mastery of basic engineering principles and mathematics and an understanding of the capabilities of the manufacturing machines that you're using. As you, again, get a little further along in your career, you might find yourself in a supervision role, and this must take the design engineer's drawings and supervise the assembly of the object as it was conceived. These folks work closely with both technicians, mechanics, and laborers. associated with the process of estimating and bidding for competitive jobs, and then employ knowledge of structured materials, fabrication processes, and general physical principles to estimate both time and cost to accomplish a task. Some other engineering related tasks: product and construction. Could be a project engineer supervising other engineers on the job, preparing schedules for production and construction. Again, you must have knowledge of engineering principles and visualization skills to be successful there. You could be operations or plant, responsible for the maintenance of the building, equipment, grounds, and utilities. Varies from routine tasks to setting up and regulating the most complex automated machinery. Wide knowledge of several branches of engineering, compare cost of operating under various conditions, and set schedules for machines so that the best use of them will be made. And then evaluate new equipment and retire old equipment, and must be able to work with people and machines and know what results to expect from them. And then another category could be sales. Could find yourself in the sales role as an engineer. In this category, you'd be presenting the use of new products to prospective customers, possess intimate knowledge of the principles involved to educate possible users so that demand can be created for that product, ability to talk their language, of course, in like plain terms, but also answer technical questions at the same time. Must be familiar with the operations of a customer's plant, must be able to show how their product will fit into the plant, ability to show the economics involved to conceive the customer to buy, convince the customer to buy, sorry, and knowing applications in which no apparatus is available and reporting back to the company that a need exists for research and development. And then we have management. So recent surveys show that a trend today is for corporate leaders in the United States to have a background in engineering and science. Leaders use these capabilities of the company to the best advantage to produce a desired product in a competitive economy. And of course, taking a look at specifically different equipment that's in the plant, the labor force that you're hiring, and of course, any financial assets that would be important to the company. Just a couple of follow-up points here. Business side of the operation that an engineer must work harder to develop, and then concerned with long-range effects of policy decisions, including financial, legal, and labor aspects related to their work. So that is both presentations in a nutshell. Hopefully you found that interesting. And like I said earlier, in this activity time today, you get a chance to explore some more of these things, do some research online, and form some of your own conclusions. Thanks for watching, everybody. Until next time.